With that, let's give a big Cincinnati software craftsmanship welcome to Chris Ayers. Chris is a speaker, technologist, nerd, gamer, and reader. He currently works at Microsoft as a senior customer engineer, and today he's going to teach us about GitHub Actions. Welcome, Chris.
Hey, Michael. How's it going?
Great. Thank you for being here. Really excited to learn more about GitHub Actions.
Well, I have some excitement that you have, around momentum. I'm excited. I'm going to be traveling up there to see you guys and share at Momentum. I'm going to be coming from my hometown down here in Tampa, Florida. So the
Cool.
song you're playing during the countdown, Clouds, Rain, and Sun. Yeah, we get lots of all three.
Yes, we've gotten some of each of those today. So that's been definitely some of that here as well. Cool. Well, I won't keep you anymore. I know you have a lot of good stuff to share. I'm going to go ahead and drop out here and have a great time. And I'll see you on the other side.
Sounds good. So hello. Today we're going to be talking about CI/CD with GitHub Actions. My name is Chris Ayers. I'm a senior customer engineer at Microsoft. I've only been here about 8 months. I've been in the field since the 90s. I've been programming at home and at school since second grade. So this has pretty much been my whole life. It's something I care about deeply and I'm very passionate about. I'm on LinkedIn. I have a blog that I need to blog more often about probably, but I've got a lot of code samples and all of the demos we're going to show today are out on GitHub. I will have some links at the end as well. These slides are also out on GitHub. These are all markdown slides. So we could talk about that. So as we dive into CI/CD with GitHub Actions, there's a couple of things I want to hit first. One, YAML. As we dive into workflows and actions, YAML's at the heart of it. It's got some pretty simple rules, but I just want to make sure everyone's aware of them because as we dive into YAML, it's used everywhere in a cloud native application. It's used in Kubernetes and Helm. It's used in workflows. It's used in Azure DevOps, YAML pipeline. So just making sure you're comfortable with YAML and understand the rules will help you when you run into weird issues or if you're trying to debug something. So just want to cover that. I also want to touch briefly on CI and CD. And I probably should have another CD there. And then we're going to dive into actions. I just got like 2, maybe 3 slides on a few things around actions, and then it's just all demos. We got a bunch of demos we're going to tear it apart, start the ground up, and then just start building. And we'll do some things in Node, we'll do some things in Docker, we'll do some things in .NET, and deploy some stuff to Azure. So we'll have a fun time. YAML. So like I said, just want to make sure we're all on the same page. Stands for yet another markup language. GitHub uses YAML for its workflow files. There's really only 3 rules that you need to care about. Like lists kind of start with dashes. Key value pairs start with key, and then the colon and a space and the value. And then objects have a colon and then maybe some indentation and some properties. So let's actually see what that looks like, just because I like to play around with stuff. So this website's kind of cool. Sure, there's ads, but I have some dogs. So maybe my dog's name is Spot. So that's a key value pair. We've got it in YAML. It's going to convert over into JSON. So remember, everything that's valid YAML should convert over into some sort of valid JSON. Now, it might not be what you're intending if your indentation's wrong. I mentioned lists. So my dog has some favorites like treats or belly rubs or naps. Okay, so we've got an array over here in the JSON. Now, maybe we want all of these things to be part of an object. So maybe I want the name of Spot and all these favorites. So now we've got an object with properties and arrays. So pretty simple. The other thing we can do in YAML that you can add comments. Now notice the comments are not going over into the JSON. So there we go. That's all I wanted to cover. We're all on the same page now. So cool. So CI/CD. Now this comes up a lot, and I just want to touch on it. Now I brought up that website earlier for the JSON validation, the YAML. I use Visual Studio Code for all of my stuff. There's some great extensions for it, and it will be. I'll show that shortly. But when I talk about CI/CD, which CD am I talking about? Now this is important because there's a distinction there that whenever you're starting to talk about automating build and release pipelines, what are we talking about? So CI is usually what I talk about when I want to, does my code build? Do I have security scans on it? Do I have secrets, validation, dependency validation? Do my unit tests run? Does it compile? And do I get a valid artifact? That's one question. Now, when I'm talking about delivery, this might mean, have I automated my deployment where I can have push button deployment? I can push a button and have it go out to an environment. And a lot of times we have automation that automatically deploys things out to a dev environment. And maybe we have a human that approves things or take a look at things or validates things before it goes into a QA or goes into a production environment. And so that's where, when we have continuous delivery, we have the capability to deliver it to any environment, but there's a human manual step involved. So when we're talking about continuous deployment, that might mean we have confidence in our pipelines. We've put in there, we want secret and security scanning. We want it to compile and pass tests. We want to maybe deploy it to an environment and run load testing on it. And if everything has passed all of the checks that we put in place, we're confident that it's allowed to go out into production. You have automated UI testing and you have automated acceptance testing, and you're confident that it's ready to go. Now, that is a decision per company, and usually you start seeing it as maturity, as companies mature and they start having a lot of processes in place, that this can help with that. So I just want to make sure that is covered, because we can touch on that a little bit. Now, actions. Actions are event driven. They are all going to live in your .github workflows folder. And if there's a public repo out in GitHub and it's leveraging workflows, you can go take a look at it. And we'll go look at a couple of projects just as we're doing it. But as I mentioned earlier, workflows are in YAML. Now, workflows are event driven. So some event happens from interacting with GitHub, and I'll go show those. And workflows might trigger, the events might trigger workflows to run. Now you can specify what events you want your workflow to run on. So you can be choosy. I only want it on a pull request. I only want it on a push. Maybe I want to limit things by a path or a branch or a tag. And so we'll talk about that. But when the workflow runs, that file executes. Inside a workflow file, there are one or more jobs. So you can have multiple jobs. A job runs multiple steps. It could be a shell command, like we're going to run a bash or a PowerShell or CMD script, or it could be an action. And actions can be JavaScript based, Docker based. There's a lot of options around those, and you can make your own actions. Now, I said there's one or more jobs. Well, each individual job inside a workflow runs on a runner. So the runner is, in Azure DevOps terms, that might be an agent where you have a piece of software installed on a VM or a container. GitHub provides some hosted runners, and I will talk about those momentarily, where we can talk about all of the software available. There's Windows runners, there's Linux runners, and there's Mac OS runners. So you can build your mobile applications on any environment that you might need to without having to most likely install or configure extra software. So let's go get to the demos. Let's go have some fun. Now, all of my demos are up here in my repo. Let me go ahead and just make things a little bigger. Yeah, that should be good enough for everybody. So like I said, workflows exist in the .github workflows folder. And I did mention all of my slides are right out here. They're right here in Markdown, so you can see those. But so we got our workflows folder. I have multiple workflows, so you can have quite a bit. I'm not sure what the exact limits are, but there are a ton of. You can have dozens and hundreds of workflows in your workflow folder if you want. Let's take a look at a basic workflow. So a basic workflow has a name. Um, that name, 00 basic, that is what is displaying if I go out here to actions. So if I go out here to actions, this is what's displaying here. So I've got two 00 basic workflows printing. I can click that and I can see which one it is. And I have two. So like I said, let's just kind of look into this and take it apart. I mentioned there's a lot of events. You can choose what events are going to trigger your workflow. In this particular case, I'm choosing 3 events. Push. So if I push to any branch, if I push code up, this workflow will run. If I do a pull request into any branch, this workflow will run. And finally, there's this workflow dispatch. This is not obvious when you first start playing around with workflows. But workflow dispatch is a way where you can manually trigger a workflow. So instead of having to push or do a pull request every single time you want a workflow to run, you can do a workflow dispatch to let you manually trigger it. Azure DevOps, you can always manually run a pipeline whenever. This is very event driven, and the events don't necessarily deal with code. They might be dealing with creating an issue or a tag. It could be that someone forked your code. Could be they left a comment. So there's a lot of options on how you can trigger workflows. They are not just for code. Now, we've talked about the triggers, and we're going to play around with these. Here's our jobs. So, we have an object that has multiple jobs inside of it. One of them is called build, and this runs on. So I mentioned that we're going to use runners, that we have lots of runners. This is Ubuntu latest. Well, if I look up GitHub hosted runners, all of this is very well documented out in GitHub. I'm a huge fan of the documentation on both GitHub and Microsoft. And that was before I worked here. So here is the hardware specs of the VMs that are going to be running your jobs. And there's lots of options like Windows latest, Ubuntu 18, 20, 2204. But more importantly, they have lists of the software. So I can come out here and look, and it's all out on GitHub, it's all open. What software is installed on my hosted runner? Well, there's everything. There's Erlang, there's Python, there's pip and Homebrew. You can mess around with pretty much any kind of language you're going to deal with. You can mess around with any cloud you want. We have Terraform, we have Pulumi, we've got AWS, Azure, and Google, Java, PHP. They even have drivers for automated UI testing. So we have Selenium drivers, we have Chrome drivers, multiple databases, Go, Python, Ruby. And so out of the box, you probably don't need to install or configure much software. There are so many things that you can leverage to build and release your software. Yeah, just kind of across the board. And all of the versions are listed. And so I mentioned, hey, I might run this workflow and I might, pick something. And then this is the definition of all my jobs. This is the definition of my build job. And here are our steps. And we will go into these in more depth, but here's using an action. It's using some sort of checkout action. And we're gonna explore that momentarily. And then we're just gonna run essentially a simple bash command. We're gonna echo out hello world. So what does this look like when we run it? So if I come over here to my basic workflow, remember I said I added workflow dispatch so that I could run my workflow manually. So I've triggered it. And what should happen is, here we go. So we've got yellow, we've got this build going. It's doing that checkout, and I can see some summary about it. So I can see the hash of my repository, the essentially the commit that triggered it. I can see what the event was that triggered it, and if I look inside my build, I can see the two actions that I picked, and then a few other actions or log entries. This is listing out information about my runner, information about the environment with links straight to all that software we just looked at. So we can, just from any of our actions, any of our runs, we can go see all of the things that were installed and available on it. Now we're going to talk about all of these different things as we go, but I just wanted to run that one first. Now I hinted at, and I didn't really dive into all of the ways triggers work and all of the events that we can trigger on. So this example here, we can say, yes, I want pushes, but I only want this workflow to run on certain branches. I want it to run when someone pushes to my main branch, when someone hits the Mono Octocad branch, when someone uses a release branch, and it has to be in the releases slash something, the star kind of anything underneath that. Or maybe any of these are like multiple ifs. Any of these can help trigger it. I want certain tags, or I want certain paths, or pull requests in the main, or this certain cron schedule. So cron is a Unix format for, this is a Unix format for like the 30th minute on the 15th, or the 5 and the 17th hour, on any day. We so there's additional, advanced kind of trigger logic that we can put in. And if we go and here are all the events that trigger workflows. Now, if you look over here on the right, there are a lot. So everything from, and let me just zoom in there a little bit because that's a big list. Running checks, having discussions. So again, this is not just for code. Interacting with the site, there's someone forked your code or opened an issue or made a comment on an issue. You could have a workflow that takes that issue and adds a comment. Yeah, we're going to look at it. Moving cards and columns around in that flow. So there's a lot of capability here, and I'm gonna talk about this a little bit to show you later some of the things that GitHub themselves have built on this type of capability, which is really incredible. All right, so continuing with building things up, here we have multiple jobs. So I've simplified things again. I just want my main branches, but I've got 3 jobs: job 1, job 2, and job 3. Now, something that is important when you're looking at jobs, you can see job 1, 2, and 3, they just kind of ran. If I run this, something that's interesting about it is we're not telling actions or the workflow anything about these jobs other than I want these jobs to run. So job 2 finished first, and then job 1. We didn't say there was any sort of dependency graph or any sort of I need this job to finish first. And if you're not careful, you can try to do your release job, putting your code somewhere before it even finished compiling. And so you want to introduce dependencies. You want to say, hey, this job might depend on that other job. And that's a very easy syntax. So let's take a look at what we had. We have the same workflow. Here's our job 1, but this time job 2 needs job 1. So we can have a little bit of, and we can hint at it. Now I also said job 3 needs job 1. So if we go and look at this run, what's going to be really kind of cool when we run this, and I did see a question in the comment. There are GitHub itself does offer certificates. You can get certifications on GitHub Actions and on uh, GitHub Enterprise. So we had job 2 and 3 depending upon job 1. So these two are going to wait for job 1 to finish. Now that job's 1 finished, these two are kicking off, and these didn't have any sort of dependency between them, and so they could both run independently. So very simple to add that dependent syntax. Now that we've got jobs running and we know a little bit about runners, what do runners actually do? Well, they run steps. So let's take a look at some of the steps that people are running. Well, you know, out of the box, it depending upon the OS you're running on, your shell might be so like on Ubuntu, your shell is going to be bash by default. Now you can override that. Like on Windows, it's I think going to be CMD, but you can override it to PowerShell. And there's a whole I think there's a whole array of I just want to find the documentation on it. Well, let's run this and I'll show you. But you can PWSH. That's the new PowerShell that's available on multiple platforms. You can pretty much run that on any OS. PowerShell, fully spelled out, is like the Windows version. You can set your own shells. So like Python, I could give it a Python script or a Perl script. And then we're going to talk about those actions that we've been kind of building up to. So let's go run this one, take a look at the execution, see what happens, and see how it behaves. Now, I said we're running on Linux. So I had some CMD shells in there and I had some PowerShell shells in there. I'm expecting some of those steps to fail. And I did tell it continue to run even on failure. Yep. So we got a lot of logs running through here. Let's take a look. So bash ran just fine. It displayed the echo, and you notice we're doing the variable syntax, the environment variable syntax for bash. It's printing out stuff. Now CMD doesn't exist because we're on Linux, not Windows. But we do have PowerShell, and we are using the PowerShell environment syntax, but we don't have PowerShell. We've got Python that works, and we've got Perl installed. And so we can set our own kind of scripts if we want to leverage them that way. Now, these down here, let's talk about that. So I picked actions, but I picked it at a commit hash. I've got versions. I'm saying just the main one. How do I know what these are and how do I find them? So if you're on the GitHub site, you might not have even noticed there's a marketplace button up here. And so we were just looking at checkout. So if I look up checkout, there are apps. That's a whole different topic. Those kind of were around before actions, but we've got a whole bunch of actions to do different things. We were looking at action/checkout. This one's by action. So let's take a look at this. Whenever you're looking in the marketplace, you can see, hey, action/checkout. That's the one we were using. We've got a blue check mark. It's a verified creator. So, that might be an Azure or an AWS or a Docker. We can see the list of versions here, information about it, like what this action is doing. They even give you the YAML examples on how to implement it, and they'll show you all of the options that are available and kind of how they work, describe them. And so if you are looking for an action to do something, you can find it out in the marketplace. And they even give you like all sorts of really cool scenarios. Like I want to check out multiple repos, and they give you how to kind of override the path of where it's going to check out. So they can kind of give you examples of how to implement these. Now, they also have links. So if I go here, that's going to take me to the GitHub repo. If it's in the marketplace, the action should be open source, and you should be able to see the source code, see how they're implemented, and you can see we got the same documentation here. So we can look and see how something's implemented. If we have a problem, we can go to the issues. We can review and see if there's an issue already out there that meets our needs, and we can comment on it. Or we can open a new one. Or if we want to provide some source code, we can go contribute ourselves and open a pull request into doing actions. So anything we're looking for will be here, and you can also make your own. There are ways to make custom GitHub Actions. So if I wanted to do something with Docker, for instance, and I come down here to Actions, we've got a whole bunch of different options that are by Docker with the blue check mark. So how to set up build X or how to do a login, and we can see I want to log in to ACR, or I want to log in to Docker Hub or GitHub Container Registry. They've got all of the examples you need right here to show how to pass in the secrets. So we're going to talk about that. Also, if I'm looking for Azure, like if I want to deploy a web app or log in, or my SQL deploy. So we have a lot of capabilities. We can find whatever actions we want to use, and then we can go work on those. Well, I mentioned variables. Let's dive in and take a look at variables, because we've got to be able to customize these actions, pass in values, and let's see how that works. In this case, we're going to define two environment variables. Now, we got E and V. We're going to pass in, for greeting, it's going to be hello, and for name, it's going to be world. Now I'm running on Ubuntu and I'm just passing in stuff on echoes. So this is defining those environment variables, and I can just access these as normal environment variables in Ubuntu. Same would happen if I was in PowerShell, or if I was maybe trying to invoke something from like Terraform or .NET, I could just access them through the environment variables. So let's take a look at this one. Let's give it a run. And I realize these are basic examples, but like I said, we're building on things. And hopefully at the end of this, you guys are going to have all the skills and examples to be able to build workflows for yourself. All right. So this one finished. Let's take a look at our script. This is saying, notice because we did environment variables, we're just saying greeting and name. Behind the scenes, the workflow is taking those environment variables I defined and setting them in the environment before the bash script runs. And so those are already there, and it outputs the right names. Now we can take this a step further. So I have this other environment variable one. And so at the job level, or at the workflow level, I'm defining two environments, or variables, greeting and location, which is at the workflow level. I'm defining an environment variable at the job level. It says job. And I'm defining an environment variable that is at the step level. So when I run this, what's going to happen is that essentially the last one, or most specific one, is going to win. So if you have two environment variables with the exact same name, and one's defined at the workflow level and one's defined at the job level one will override the workflow. And then if we take that and have one also at the step level will override the job level. So if we look at this is hello world from that step. So it's kind of a last one in wins. Everybody on board so far? I see a couple of comments, but now someone did mention something in there that they don't see YAML handling placeholders or values by default. The dollar hash or dollar bracket type syntax, and we're about to get to that. GitHub does add some stuff to the YAML. Azure DevOps added some similar things to the YAML, just like Terraform has a domain specific language, you can start doing a little things like, hey, if maybe you only want to run certain steps based on conditionals. Are you in a branch that is main, or are you in a dev branch, or are you in an environment, or is there a tag? And you want to control if a step or a job runs based on some sort of conditional value. Well, we can do conditionals. There's this if syntax that we have, and we have this syntax, which we'll talk about. This is for an expression, and this is something that GitHub has added to their YAML syntax. So when we're running conditionals, maybe we only want, like I said, certain steps to run. So we've got here, and we're just waiting. I'm leveraging. Yep. So we've got run hello, run goodbye. Only one of them actually ran. Only hello ran. And if we go back and we take a look at that file and just kind of validate it, I'm setting the greeting to hello, and I only run the step if greeting is hello. This one, it's not equal to goodbye, so this step did not run when we looked at that uh, log. So we can say, hey, maybe if it is a pull request, I don't want to deploy out to production. Maybe I'm just wanting to run on my builds. And then when it gets pushed into main, then I'll do my build and deployment. There's some different options we have. Well, let's look at that syntax a little bit more and some of that capability we have. So expressions. So when we're dealing with expressions, there's actually quite a bit of it's not extensive, but there's a number of options we have for formatting, for conditionals like, hey, do certain things end with these letters? Do we have a string that contains some value? Do we have an array that contains some value? Can we do joins on strings? So we can um, have some sort of logic. Maybe we're dealing with environments. We have an array of environments, and we're just checking to see if something's in a valid list. Maybe we're joining up a couple of options into a single string for some reason. So those are all called expressions. And it was right there. Oh, well, I'll just. So yeah, so we have a number of functions over here that we can leverage: contain, start with, ends with, format, join. The to JSON and from JSON are going to be huge. Maybe you're doing a call out to a service, a REST call. You're getting response back, and you're parsing it. Maybe you're using a config file that's defined in JSON, and you want to pull it into an object and have that object so that you can pass it as an environment, or specific fields as an environment. Maybe you need to know if a step succeeded or failed or was canceled. So we've got some options, and we've got um, like filtering capability where we can uh, pull out certain properties of objects as we go. So there's a lot of cool functionality here, and I'm just printing those out just like all the other environment variables as before, but I'm using that expression syntax to get the values and transform the values. All right, so we've got uh, ends with was true, and we can join things on strings. So pretty basic stuff there, but these are all the building blocks we're going to need. And you've already seen contexts already. I'm gonna describe them a little bit more. There's a bunch of contexts out there. So we've got our expression syntax. We're converting these objects into JSON, but we have contexts around GitHub, around jobs, steps, runners. there's a number of contexts. One of them, by the way, is environment variables. Another context is secrets. So we're going to explore these momentarily, but even needs and inputs is a context. And so, what's in these contexts and why would I care or want to use them? Well, the contexts, when we look at them, these have a ton of information. We'll understand our repo and the owner. Maybe we need which branch we're on. If it was a push, what event? We're looking at if it's a fork, the licenses that are available. Master branches, build. So we can leverage this, build IDs and things, information about did our job succeed or what steps do we have if there's any outputs there, the runner we're on. So leveraging some of this information, we can then maybe we want to label our build output based on a run ID or a build ID. So we can leverage our context to get that information and dive into, hey, this is, it was a push. Here's the branch we're on. Here's the SHA hash of the workflow, and I'm going to show that in some demos later where I'm leveraging it. But like I said, one of these contexts is environments, which you've seen us kind of playing with a little bit. Another of these contexts is secrets. So secrets are going to be a way to get this information that we don't want checked in. You know. That actually will alert us if we check in, and maybe we want to be careful how we pass things. So we can leverage context, and we could just put it in on our command line, and I'll go show you the workflow file in a second. GitHub is trying to be smart here and not show this secret because it gets string interpolated, like it just puts the raw value right there in the command line. But what this means is if there was another process, maybe you had another job or someone trying to be nefarious, and or you were doing something in Docker and was exposing things, like that could show up as PS. Like if you were looking at all of the running executables on a system and you did like a PS in a Linux type environment, you could see that on the command line. In Windows, if you were looking in the task viewer, you could kind of see some of these commands with those things passed into it. If you're leveraging environments, though, you're still passing in just the environment name, but it's going to not show these things as it passes through. There are some best practices around secrets, and we'll talk about those. But notice I don't define an environment for name. That's coming from secrets, and so we still are using that expression syntax with the dollar brace, and we're using the secrets context to just access .name. And we're gonna go take a look at where that is. Just one sec. Now, if I accessed .name and it didn't exist, what would happen is it would just come back as an empty string. So if you try accessing a secret that does not has not been defined in the system, you just get nothing. But settings are over here. Secrets are over here under settings, and we can come down here to secrets and actions. So I have a repository secret name that I've got here. When you are dealing with GitHub organizations, you can have org level secrets. So you can have at the top level org secrets defined, maybe Azure credentials or something, which we'll touch on in a second. There's actually much better ways to deal with that now instead of storing some credentials. But you can have org level secrets, you can have repository level secrets, and then you can have environment level secrets. So there's multiple levels of secrets that we can deal with. And let's actually talk about those environments right now. So I just wanted to get back to the page. So when I define an environment, they are right here. So you can create additional environments. If I want to make a CSC environment, I configure that environment. Now they do offer some protections. So this is where if you didn't add some of these things or maybe added some additional REST calls or some sort of thing to add approval processes in place, you might just automatically deploy to dev, QA, and prod because there's nothing slowing things down. You might want to say, hey, I would like a reviewer on to take a look at this environment. I need that person to review things before it goes into this environment. They have to do an approval. Or maybe they've queued up this environment and maybe we just want to wait 15 or 30 minutes before we deploy as we're monitoring the old environment. So we can set up some of those protections. But some other things we can do that they've added to environments, which are really kind of neat for me. Maybe I only want this to be able to be deployed to from my main branch. I don't want my dev branch ever going to production. So I want to, or the feature branches that somebody wrote, I just don't want them going straight to production. Maybe I only want a certain branch. You know, I only want main to be able to deploy to this environment. That's it. Nobody else. And then I can add specific environment secrets. So just like before, where we had workflow level environment variables, job level environment variables, and step level environment variables, we can have org level secrets, repository level secrets, and environment level secrets. And the environment level one will override the repo, and the repo will override the organization. So those are how you can leverage environments. And I'm going to show that momentarily when I try to do an approval. Now, I'd hinted I'd hinted at about matrices before, and let's take a look at what a matrix is. This is really important if you're running software and releasing software for multiple environments, or maybe you're doing a library. I've got a couple of filters here where I just want it to run on just one branch or one folder. But when we have a job, we can say there's a strategy associated with it, a matrix strategy. And so maybe I want my code to build for node 12 and node 14 and node 16. I want to make sure it's compatible with all three versions. Also, we sometimes run on Linux and we sometimes run on Windows. So this is essentially going to build your software 6 times because we've got 2 dimensions on our matrix. We've got 3 node versions and two OS versions. And so this will essentially copy this job 6 times. It'll run on 2 different OSs, 3 times each, and it'll do these steps. And so we're using the matrix context with the expressions, just like we were using before, to access the OS version, to pick our runner, and to use the matrix version to pick what version of node we're going to install and configure. And so when we run this, it will kind of fan out and build 6 different times. And it looks really cool when you see it. And so you can control this. You can add, there's syntax in the matrix to add an additional one. Maybe you want Mac OS only on 16. You could add one individual combination if you wanted. You could exclude things. You could say, I don't care about node 12 on Ubuntu. And so you have a lot of control over what runs and doesn't run. So we can see all the jobs. We can see if they're all running in parallel. And like I said, we've got that. If I come down here, yep, we've got matrix. Yeah. And we can play around with different setups. We can yeah, in this case we're using a config file that is JSON, and we're kind of, maybe that's getting passed in. We're calling it through an endpoint, and we're passing in the payload of the versions we want. This is taking that apart and opening it up using the GitHub context. So we're feeding one context with another context. And I mentioned maybe we want to add certain combinations. So you have a lot of control as you're doing this. Now, maybe you don't want to kick off 20 jobs all at once. Maybe you only want two to run at a time. You can kind of limit that pretty easily. All right, so let's go back here. Got one or two more examples, and then we should be pretty good. Now, I did mention environments earlier. I didn't really touch on it much. I was just thinking about when I was looking at that concurrency. They do have concurrency where we can limit how many jobs or things are touching an environment or context at once. Maybe we don't want five different jobs all deploying to production at the exact same time or our staging environment. So we can tell it, hey, only one workflow. Maybe you kicked off five runs. Maybe one workflow uh, is allowed to deploy to this given environment at any time. So we can leverage concurrency to kind of control. You can even like cancel things in progress. You can cancel new jobs. Like there's some capability you have there. All right, so let's look at some simple ones. We looked at the .NET. I think a lot of people like Docker. Let me bring this up. So I will. That size okay? All right. So very simple Docker file. I'm going to copy an index file, which is this hello. I'm going to copy a directory into my Nginx HTML folder. This is where if you just want to make like a static host, you can kind of do it this way. Locally, if I were uh, do this, whoops, got out of my folder. All right. I could do something like a Docker build, something like that, and tag it, and I could build out my Docker site. I could publish it. I always tell people, I might not be an expert on your language. If you're trying to do something in Java or in certain flavors of Go or Ruby, I might not know all the commands or things to build your software. But if you know how to build it via command line, if you know the steps I need to take, we can pretty much automate it. So, if I wanted to automate a Docker image, well, um, I could I'm going to use my checkout. I want the source code from my repo in my current working folder. And then, I looked earlier, I wanted to do Docker Hub. Maybe I want to push my image up to Docker. So I'll look at GitHub or Docker. Here we go, Docker login. So Docker login, I'm going to log in the hub. So to authenticate, create a pat, and I set it two secrets. So I'm going to set a secret for my username and a secret for my token. And so if I look here, I've taken that same command and just brought it straight over. And if I go and look at my environments, I've got an environment for Docker. And I've defined just in my environment the two secrets that documentation says I need to go have. And then the other thing I want to do is I want to build and push my image. Well, there's an action to build and push. And this is you can build it with BuildX if you need to do multiple platforms. I was not going to, I was just going to do something basic. So let me go look at the usage. Here they're setting up Kemu, they're setting up BuildX. They do the login, and then they're just saying, I'm going to build and push is true, and I'm going to give it some tags. So I've got, hey, I'm going to build and push. I gave it a folder name just because I'm in a different folder. But yeah, I'm pushing it and I'm giving it a couple of tags. So I know that I'm going to call it static site off of my username. So it's going to be my username slash static site. And I'm actually giving it two tags. I'm going to tag it latest, and then I'm going to use that other expression to get a GitHub context and give it the SHA hash. So when we run this, you know, I could, if I didn't want to use these actions, I could do just some command line bash stuff, Docker uh, build and push. So it's checking out my code, it's logging into GitHub, and it's building and pushing my stuff. So let's take a look at, see it's login succeeded. And we can see it logged in and then build and push. So it's showing me the Docker version that was available. I didn't install any Docker stuff. It was all here. Gave me an info. It already had buildx and composed install. That was fine. I can see the command line it's using with the two tags because I used my username as a secret. It started out some of those. It tries to be smart. Occasionally, stuff can slip through, so don't rely on that to always hide stuff. But now if I go out to uh, Docker Hub, for instance, static site, here we go, just a minute ago. So I've got the hash and latest. So I just pushed it up. And you can see I just have the one architecture. So Docker works relatively easy. Let's do a little bit more of a complex example. Let's look at .NET. So in this particular case, we've got something waiting for my review. I'll look at this. I do a build. I set up .NET caching. Let's actually go look at that workflow file, and we'll come back and see what that's waiting on. Now you can you can either do paths or ignored paths. I wanted certain paths, like I want, if I change this folder, I want it to build. So if you want to ignore other things, since you can't do paths ignore, you can use an exclamation point to say like not. So not everything, and then only the thing I want, essentially. But let's take a look down here. So we're running on Ubuntu latest. We are checking out our code. We're using a setup.NET action, and we're giving it a version we want. Now there's a lot of setup actions, and then using cache. That's kind of a new one too. So let's just go back up here. Look up setup for one. So there's, I need a certain version of something. Like I need a certain version of Python, or I need a certain version of Terraform. I can come in here and I can invoke these and tell it the versions I want. And there's my examples. I can set up multiple versions. If I was building a library, maybe I wanted to do a matrix. So I've got that. I can even tell it to use my global JSON file. Cool. So I set it up, and then the other thing I did was cache. Now, this is a very simple example, but there are some repositories that have big dependencies. So you've got tons of stuff that you're downloading, and maybe you just want it to cache some things. Maybe if you're building multiple projects and they're all restoring, you want to cache things. And so there's some examples here for caching, NuGet packages from .NET, or pip packages in Python, or npm packages in Node. So we can come in here and I can go right down to, need to scroll down a little bit. So with lock files, I can say, hey, using this path, here's the key to cache my stuff. And then you can even kind of exclude certain ones. And there's examples for multiple languages and things. So I've included that, in case it was a bigger project. I'm doing a restore, I'm doing a build, and I don't need to restore because I already have. I'm running my tests. And I don't need to rebuild it because I already built it. I'm just publishing it to a local working directory. Every time my pipeline runs, I get a new copy of the environment. And then I'm just doing an upload. I want to save this web app folder as an artifact named web app. And then I want to upload my infrastructure as code. I got a little bicep here. So it'll build out my environment. My deploy needs my build, and it runs in the .NET environment. So it's going to download my artifact and log in, deploy it out. I've got a subscription, a resource group. I'm going to be deploying my bicep template, and I'm giving it an app name. And then, I'll go ahead and show this. I don't have anything in this resource group. It's empty right now. And so I don't actually know the name of the web app that's going to get created. The bicep file takes that in, does some variables, and so I'm actually needing to get the web app name from a previous step. So I'm going to use the steps context, and I'm getting the deploy step. So I had an ID of deploy. I'm getting my deploy step, and I'm getting its outputs. And this particular step bicep file had an output called web app name. So I'm going to dynamically create some infrastructure, and then I'm going to deploy a new web app to this infrastructure that just got created. And we're in our .NET environment. So if I look at my .NET environment, just to kind of tie it back together, it's got a protection rule. I need to approve it. And it has those secrets that are only for this environment. So now when we go back and we look at that action, we saw it had a waiting. It's waiting for an approval. See, it has requested me to review it. I can look at my build. All those things set up. It set up the SDK, ran the tests, did the publish. It uploaded an artifact. It's telling me how many files will be uploaded. I can even go back here, and if I'm looking at like a previous build, I can see the two artifacts. So I can see these two right here. These were produced during my runtime. I can download them and review them. But let's go ahead and approve this and let it run. So am I allowed to deploy this? Yes, I can leave some comments. I'm going to go ahead and approve it. So now it's going to start the deploy. Bicep is a new version of ARM templates. So to deploy to the Azure cloud, the native templating language is called ARM, Azure Resource Manager. Bicep is a newer version of that. In AWS, I think it's CloudFormation. And then you can leverage Terraform as well. So Terraform is a domain-specific language in HCL, HashiCorp language, and it is cloud agnostic. Like you can define data modules and resources in Terraform and then use those to call out to providers. Now, there's a misconception on Terraform is that it's like you can write it once, deploy many times. That kind of not really a thing if you're doing multi-cloud, because the providers for Azure use different properties and different resources than the providers for like an AWS or Google. And so you might have data files that are shared amongst them, maybe like subnets or naming patterns. But when you actually have to deploy it, you have to re-implement your modules, usually per provider. So, and that could be an on-prem Docker or Kubernetes thing, or a cloud-based thing. But it's the same language across multiple providers, but each provider is usually very closely tied to their cloud. All right, so the login happened. And I do want to talk about this because this stuff is so cool. I'm using an older method of logging in, an older example of logging in, which I have a service principal. I've created an account in Azure that is going to be used to authenticate this workflow to Azure to give it permission to deploy my resources, deploy my infrastructure, and deploy my code. So I'm using a service principal. There's a different way called OIDC, OpenID Connect, and it's much more secure because you're not storing in your secrets a password anywhere. There's some sort of backend trust between GitHub and Azure and a couple other providers. I'll show that in a minute. So this did my ARM deploy. And if I look here, I had some environment variables for my .NET, but it made a template, it validated it, created my deployment, and had an output. It downloaded my artifact, and it's showing me the folder it ran in. And now it's run the deploy, and it has an app name that it got dynamically, and it's showing me, hey, my URL because it's successfully deployed. So if I come out here and I refresh, I now have an app service plan and I have an app service. So this is how we do things in Azure. And I've got a URL here. I made a examples, super simple example, but it just spun up. Everything just got created, and should return a nice little message momentarily. Always like this that first spin up. There we go. Hello. So um, that is most of this. Now, but maybe you want to get started. There's a little new workflow button here. Okay. I can say, I want to do it myself. I've got all the skills. Chris has trained me. We're going to be awesome and we're going to go build workflows. Or this looked at my repo and this is saying, hey, you've got a node thing. Would you like me to give you a sample node thing? Would you like some help finding marketplace issues? So there are a number of starter workflows that GitHub provides that you can go out and take a look at. And there's a couple of really cool bonus things I want to show you guys in just a moment. So like for CI, well, guess what? There's lots of examples for CI. You know how to build Haskell? They know how to build Haskell. They know how to cache it, set up Haskell, the right version, install your dependencies. Guess what? Here's a great example that does all the things, builds and runs and tests it. That's cool. Maybe you've got to do some Objective-C with Xcode. Well, guess what? It's running on Mac OS. I want to set up maybe Scheme and Xcode build and run on my Xcode build. They've got examples for this stuff, and it's awesome. Notice there's a couple of other things in here. So there's code scanning. Maybe you want to do check marks or code QL. So code QL is really, really, really cool. Or it actually looks in your source code for like OWASP violations, and it treats your source code as data and can look for like dependency injection issues. Really, really neat. Maybe you want to scan your containers with Sneak. They've got sample workflows to come in here and like take a look at it all. Now, a lot of this stuff we're talking about is CI/CD. What if you could make an entire training platform out of workflows? GitHub did. That's what skills.github is. It is so cool. So you can come in here and you want to learn how to use or create GitHub Actions. Says use this template. Well, okay. Well, how are they doing stuff? Well, I can come into GitFlow or GitHub workflows. I can see what they're doing because it's all open and the workflows are here. So it's looking for certain branches, and then it's going to, hey, if this is not a template, hey, go run this script, do this stuff, update this step. They've built a training platform out of actions, and it will teach you how to use actions. It'll teach you how to do continuous integration. So there's some really cool stuff in here. And then let's see. I also have made a collection. So I mentioned I work for Microsoft. I put a collection out here. If you've never heard of Learn, it is absolutely amazing. So there is a Learn module. So these are and this is a learning path. It's free. You can just come out here, and these have content. These have um, diagrams. These have exercises. These will take apart stuff and explain it again. They have knowledge checks in them. Sometimes they will spin up environments and let you do stuff with the environments. If you've never used Learn, this stuff is really, really, really cool. And they have a number of modules I've gone through and I've picked out in my collection a number of modules that are specific to GitHub Action. I've got a link to that skills page. We've got web pages for the documentation, like understanding GitHub Actions and getting down in here to the expressions and the contexts. And then this one's huge. The high level workflow syntax for actions. So using a single event, using multiple events, using different activity types. Like they have so many examples and so much just content defining all of the things. I want to run a command. I want to run a command on different shells. So it's all right here. So that is all I have. I really would like you guys to take some time to try out these things. So go explore GitHub Actions, go play with things, go try things out, go look around GitHub. You can find all of these actions out there. You can go figure out how to write your own, or you can search code. You can say, I want to search for .github/workflows in all of GitHub, and you can go take a look at some of the workflows that are out there, and just see how people are building things. So I'm gonna stick around on the Zoom call after this, but feel free to follow, reach out.
Cool. Thank you so much, Chris. That was really cool. I learned a lot in the process, and I hope everyone else did. Definitely, if you're interested in learning more about GitHub or other actions, things like that, follow Chris, check out his blog. Chris, anything else you want to call out?
No, just it's all out there. It's all open. There's great docs. Go play. Go have fun.
Awesome. Cool. It's been wonderful having you. Can we get some applause in the chat for Chris? That'd be awesome. Don't forget to stick around after the talk for our Zoom discussion with Chris. So, Chris, we'll see you there. And
sounds good.